Today, what we're going to talk about is the types of errors that you can make when conducting a hypothesis test. And we're going to talk about what an error is and talk about it in context and when can you possibly make this error, right? And it's not letting me go. There we go. All right, so when you perform a hypothesis test, you're going to make a decision. What decisions do you make when doing a hypothesis test? You're going to do one of two things, right? Reject or fail to reject the null hypothesis, right? You guys agree? So when you perform the task, you either fail to reject HO or you rejected HO. No other third possibility, right? Question for you. When you make one of these decisions, there is a possibility that you could be wrong. Which means if you rejected HO, maybe you shouldn't have. Or maybe when you failed to reject HO, you should have. And there's going to be errors along the way, right? So yesterday when we were doing our animal cracker activity, what did we end up concluding? They were overfilling the boxes, right? So we rejected HO. What if we were wrong? Could we be wrong? Possibly. What's the probability of us being wrong? Can you find that? Maybe. All right. Interesting thoughts, right? Now, question: if we could make an error, do we want to reduce the probability of making an error?
Yes.
Why? Because if we're going to do all this work, we might as well be correct. Doesn't that make sense? Okay. So we're going to talk about the types of errors that you could make and the probability of reducing. And there's going to be a giant factor at play that helps you when reducing error. Okay? You guys with me? Okay. When testing a claim about a population using a sample, it's possible you could have made an error. The two most common types of errors that you can make are what is referred to as type 1 error and type 2 error. So there's going to be type 1 error and type 2 error. And there is obviously a difference between the two, right? But that's what we're going to call them. So this is going to be type 1 error and type 2 error. Type 1 error. This is when you reject HO when HO is true. So this is when you reject HO, but you shouldn't have rejected it. So when we're talking about type 1 error, it's rejecting HO when HO is true. I like to refer to this as rejecting true host. That's just my slang way of saying rejecting true host. There is a probability attached to a type 1 error, and it's very easy to find. The probability that you make a type 1 error is connected to your significance level. That's interesting, right? So if we wanted to reduce type 1 error, what do? Reduce the significance level. That's pretty easy. Well, kind of. Not necessarily. Yep. But it's going to do something else, and we'll talk about the connection. Right? So here, you can kind of choose the probability of making type 1. What do we generally default our alpha level to? You ever wonder why we don't do 0.01? Or 0.001? Because that would reduce the type 1 error very significantly, right? But as you're going to learn in this section, as one error goes down, the others goes up. So you kind of have to find a balance between your errors, because we haven't talked about type 2 error. But I'm telling you already, as a preface, the lower type 1 error, it's going to be inversely related to type 2. So you kind of have to balance out your errors. Does that make sense? All right, so what this means is the probability of making a type 1 error is equal to our level of significance. So it's that line right there. It's the line in the sand, basically, is the probability of you making a type 1 error. All right, so type 2 error occurs when we fail to reject HO when HO is false. So you didn't reject it when you should have. So that means when you conclude and you say, hey, we could reject HO because the P is low, the only type of error you could have made is type 1. Because type 2 error deals with failing to reject HO. So when you conclude that you fail to reject HO, what's the only error you could have made? Type 2. So when you reject, you make type 1, possibly. When you fail to reject, you could possibly make type 2. You can't make type 1 and type 2 with one decision. So when you reject type 1, when you fail to reject type 2. Does that make sense? I refer to this as not rejecting fake hose. Your hose false, and you didn't reject it, so not rejecting fake hose. And remember, when I talk about a hoe, it's a null hypothesis, not rejecting fake null hypotheses, right? H naught. Okay. Type 2 error is what we're going to refer to as beta. Right? For the scope of this class, we're not going to calculate beta. We're not going to calculate the probability of type 2 error. If you take stat classes after this, that's within the scope of their classes, but we're not. Right? The only thing that you need to know about beta is that it is linked to another concept that we're going to study tomorrow called power. So beta is linked to power. So jot down what you need to. Okay, funny diagram here. So this is fun, right? So this is type 1 and type 2 error. I mean, these are kind of funny, right? Rejecting HO when HO is true. You're not pregnant. I'm trying to think of like what the null and the alternative hypothesis is. Let's come up with that, right? So this is when you reject HO. So type 1 is when you reject HO, but HO is true, right? So let's say HO is you're not pregnant, right? But you reject it, saying you are pregnant, but you're really not. So you reject HO when HO is true, correct? So this one is you reject the fact that you're not pregnant in favor of that you are pregnant. So this guy is like, oh gosh, I'm pregnant. Over here, you fail to reject HO when HO is false, right? You say to this person, hey, you're not pregnant. What? You guys see why it's funny? Okay.
You make this yourself.
No, but I mean, this is a great example of it, right? Given that the null is you're not pregnant and the alternative is that you are, these are the type of errors in context. So it gives you kind of like a visual. Here's even more of a visual, right? So two different people. Because you're going to have what you conclude. You guys see the study conclusion? This is what you did, and this is reality. Okay. So if you say you have a significant result, but you don't, that's a false positive type 1 error. If you have a not significant result, but you say you have, but in reality you do, that's a type 2 error. This is rejecting HO when HO is true. This is failing to reject HO when HO is false. All right? And we're going to do this in another diagram in just a second. So here's the truth. Either HO is true. Now you're going to copy this on your notes. Either HO is true or HO is false. And if HO is false, that means that we have evidence to say that HA is true. Does that make sense? Okay. Our decision comes here. So we're going to make a decision. What are the two decisions that we're going to make when doing a hypothesis test? You're going to reject or fail to reject. That's going to be the same thing, right? So let's go through each box and see if it makes sense. Should we reject HO if HO is true? Should we reject HO if HO is true? No. What does that mean if we reject HO but HO is true? Type 1 error. That'd be type 1 error. Does that make sense? What happens if we reject HO, but HO is false? Is that what we want to do? Do we want to reject HO when HO is false? Yes. Smiles. What if we fail to reject HO, but HO is true? Smiles. We don't want to reject something that's true. But what if we fail to reject something that's false? Okay. With my nice PowerPoint colors and stuff. There you go. So that box kind of helps you organize what's going on here. Right? So either on this screen or the previous screen, you got to remember there is what we conclude and what's actually true. Does that make sense? There's two things: what we conclude and the truth. Sometimes they match up. Yes, our decision should match the truth. But sometimes do our decisions not match the truth? Sometimes they're wrong, right? This is almost like when you think you have enough evidence in a murder trial and you don't. So let's think about that, right? HO is you're not guilty. HA is you are. You reject HO, you're not guilty, in favor of the alternative, you are guilty, right? And we'll talk about that example in just a second, right? But we're going to bring that back to light. Okay? So it's like I knew that was coming, right? So consider your murder trial. What are the hypotheses? We just quickly talked about them, right? HO is you're innocent or not guilty, basically, right? Defendant is guilty. Not guilty versus guilty. You guys remember us talking about this in the very beginning of chapter 9? How much evidence is enough evidence? Overwhelming evidence. But sometimes you can make a mistake, right? So what is a type 1 error here?
You didn't do it.
You reject HO.
And he said, you're guilty.
But it's true, right? So what happens if you reject HO here? So I want you to think about it. You're rejecting HO. You're saying that the defendant is not innocent, in favor of that they are guilty, right? But it's true that they're not guilty. So basically, you decide the defendant is guilty when they're really innocent. Is that a good thing if we decide the defendant's guilty when they're really innocent? Probably not. That's sending innocent people to jail. That sucks.
Like truth will say, I'd rather one guilty man, or I'd rather 1,000 innocent men be locked up than one guilty man run free.
Henry alluded to what the type 2 error is, right? This is failing to reject HO when HO is false. Failing to reject HO when HO is false. You literally look at the statement, and you look at that statement, HO is false. This is not a true statement. The defendant is not innocent, but you said they were. So you said the defendant is not innocent, but they are. So this is the defendant is not guilty when they really are guilty. So the defendant is not guilty in favor of the alternative that they are. So this statement is false. The defendant is innocent is false. But you don't reject it. So these are sending innocent people to jail, type 1. What's type 2? Guilty, go free, right? So what's the consequence? Well, innocent person goes to prison. That's an effect. Do you guys see what a type 1 error is? It's literally talking about the hypotheses themselves. The consequence is a result of doing that. Innocent people go to prison. And we just talked about the type 2 consequence, right? A guilty person goes free. as a society, what do you guys think that we think is worse? Putting innocent people in jail or setting guilty people free? As a society, which one do we think is worse? Type 1. Type 1 is definitely worse, right? This is why the court systems say, beyond a shadow of a doubt, there is overwhelming evidence, correct? So that means that you have to literally, you're innocent. That's why that phrase comes from. You're innocent until they prove you guilty. And that's trying to avoid type 1 error. Because they do not want innocent people in jail. Is that always the case? No. Same thing in our hypothesis testing. We try to make sure it's the best, but sometimes we can't control it. Okay? Okay. Why would we make type 1 and 2 errors? Well, just like humans, hypothesis tests and statistical tests are not 100% accurate. The biggest flaw that leads to these errors is shocking enough. I know you guys are surprised by this. When do we make the most errors? When we have low sample size. So how do we fix that? You increase the sample size. So increasing the sample size here would fix that. So not only the sample size increasing the sample size, decrease margin of error, reduce variabilities, it now, as of today, lowers the probability that you will make a statistical test error. A type 1, type 2 error goes down. So as sample size goes up, margin of error, variability, and the probability of making a type 1 and 2 error are all reduced. Who knew that raising something so simple would have so much of an effect? Who knew? However, guess what? You were here this morning, we had this conversation again. Raising sample size does not fix bias, and it never will. Okay? Never will. All right, you guys good? Did you jot down what you needed to? All right, continue on. So every time you make a statistical decision, you could have possibly made a type 1, type 2 error. Do you guys know what you did on your performance test? What did you do? Failed, reject, or reject? I got scared. Failed. Failed or reject. So what type of error could you have made? I'm just going with what the majority said. I don't know if it's accurate. But assuming that you guys were right and you quote unquote failed to reject HO, what type of error could you make? Type 2. You could have made type 2 error. Okay. Now, what you need to understand is the reason that we use 0.05 significance level is because not only are alpha and beta related, they're inversely related. That means as type 1 error goes down with your significance level, what increases? Type 2. So remember that this is going to be alpha, like this is going to be alpha level, but over on the other side, it's beta. Do you guys see here? Yes. As you move one to be smaller, the other gets bigger. Okay? So as alpha decreases, beta increases, and vice versa. Okay. You guys go with that? Okay. The seriousness of the error is dependent and determined by specific situations. Now, in certain situations, you're going to take a look at the consequences of making a type 1 error and of making a type 2 error, which is really how you should determine what significance level you use. So for instance, if you go type 1 error and you say, well, no one cares about type 1 error, it's insignificant, but type 2 error is like super, like it will cause lots of issues, maybe a lot of potential harm to people. Well, which one do you want to reduce? If type 1 has no effect and type 2 could kill people, which one would you want to reduce? Type 2, which means what would you need to do with your alpha level? Increase your alpha level. Maybe make it like 0.10. And if you make it with a higher significance level, guess what's going to reduce? The probability of making type 2 error. Also, you want to make sure you have a high sample size, correct? So those factors there will contribute to lowering type 2 error. Will you know if you made a type 2 error? No. It's kind of like you never know if P or mu is actually in your confidence interval. Like, you'll never know. Actually, you kind of will, because if one causes harm to somebody, if someone dies, then you'll kind of know you made that error. Oops. All right. Hopefully that doesn't happen, right? But that'd be really bad. And I just kind of talked about it, right? Sometimes these errors in real life, we don't know they happen until something issued. Okay, so back, I think it's like in the early 2000s, if I'm mistaken. It's either in the late 1990s or early 2000s, where they had Firestone tires. There's like this giant recall because they were talking about people like who had them were hydroplaning, like seriously, like in the rain. So they had to do a tire recall. Okay, and these were causing more accidents than normal. So basically, when they were manufacturing tires, what happened was they distributed these tires, they were defective, so people were having more accidents. So something was wrong with like the manufacturing piece of the tire. So because they didn't catch that, they sent these tires out. That's why you see recalls. Do you ever like hear in the news like sometimes it's lettuce being recalled, sometimes it's cars being recalled, sometimes it's like, you know, what? Chicken nuggets being recalled, because there was some sort of issue that happened that the manufacturer didn't catch. Maybe it was like something that was out of control they thought was in control. Do you guys remember us talking about the control limits with the filling up of the animal crackers? So how many animal crackers, like what's the weight need to be before they realize there's a problem? This is what happened. Like people didn't realize there was a problem, but there really was. That's one of those errors. You guys understand what I'm talking about? Like there was a big error, so then they had to do this giant recall because they figured out, hey, something's going wrong. Okay. Fen-phen and Vioxx were weight loss drugs. They end up giving people heart attacks, from what I remember. Oops. So beware when you take medications. Side effects are a thing. Okay. So, consequences to our actions. Now, if we make an error, of course, there's going to be consequences. We just talked about the murder trial, right? One big thing, please highlight this when you get there. A consequence is not the definition of a type 1 and 2 error. It's the result of it. So please make sure that you highlight, star that. Consequences are not the definitions of type 1 and 2 error. They're the consequence of it. Now, when we're talking about the consequences to our actions here for our errors, there's going to be two things that we need to look at to pick out the best consequence, or the most, I guess, detrimental consequence to the scenario. You got to look at the scenario, obviously, and the point of view. Yesterday, I told you, who's going to be happy if the animal crackers are overfilled? The consumer. Who's not going to be happy? You guys see how the point of view shifted? If it was reversed, if they were underfilling, who's going to be happy? Nabisco, because they're saving money and still, charging you full price for a product they're not giving you what they advertise. Who's going to be mad? The consumer. It depends on the point of view. You guys see that? It also depends on the scenario. So you got to kind of have to weigh the scenario with the point of view, right? Figure out the best ones. Remember, we don't want errors to happen. So those companies like Firestone and the companies that produce those medications, they have now learned from their past mistakes due to these recalls that they need to have some sort of extra quality control. More testing before they put things on the market. This is why, like, the American drug, what is that? It's like the FDA, Federal Drug Agency, right? You guys learned about that in Stokes? Yeah, you knew what I meant. Anyways, that's a thing now, right? And it's making sure that it keeps people safe when companies are offering different things like foods and drugs, right? They need to go through certain testing, FDA requirements, right? Let's do some examples, shall we? Okay. So let's say we have Lay's Chip Company decides to accept a truckload of potatoes based on the results from a sample of potatoes from the truckload. So we have potatoes, and the company is either going to accept them or not accept them. So what are the hypotheses here? HO, the potatoes are good. HA, the potatoes are bad. Either they're going to accept them or they're not going to accept them. Okay. So type 1 error. So let's think about this. Type 1 error is when you reject HO, but HO is true. So the statement that the potatoes are good is true. But you reject it in favor of. So you say they are, but they are. You guys see? The potatoes are bad, but they're really good. So you have to literally look. I literally look at the null hypothesis and I'm like, this statement's true, but I did this. Or I say, this statement's false and I didn't reject this. Because when we do type 2, I'm going to look at HO, the null hypothesis. And I'm going to read that statement. Potatoes good. That statement is false. The potatoes are not good, but we said they were. We decide that the potatoes are good, but they're not. Does that make sense, what I'm doing? Like literally, you stare at HO. It's either true or it's false. When you make an error, that means you say it's true, you reject it. Oops. If you fail to reject it because it's false, oops. If you reject it when it's really false, yay. You see how that can go? All right, so let's think about this. From the supplier's viewpoint, what is the supplier doing? They're providing the potatoes to who? Liz. Which one's more serious? Deciding the potatoes are bad when they're really good, or deciding when the potatoes are good when they're really bad? Type 1 error is worse here for the supplier.
Yeah, but backlash.
Okay, well, think about this. The supplier is bringing the potatoes. I'm bringing you potatoes. You say they are bad, but they are. So I have all these potatoes that are just perfectly fine. You don't want them. So now what do? I have this whole truckload of potatoes. You're not taking them. Why? They're fine. No, they're not fine. They're fine. We checked 15 times. They're fine. Nope, not taking them. So what is the supplier now? I probably irritated.
Well, you could be like, are these good potatoes? But yeah, they're fine, but they're actually like super disgusting. Yeah.
That's this one.
No, but that's for the second.
So because Lay's,
potatoes are bad.
so from the chip company, they want good potatoes, right? So if they're like, oh, these are good. Okay, great. They're great. You start making potatoes. These are bad. Not good, because now they have a whole bunch of potatoes that are bad. They're supposed to make potato chips. Can they provide Anna with bad potato chips? Yeah. I mean, they could, but then Anna's going to call the 1-800 number. Your potato chips suck. Okay, well, I mean, that's going to be an issue for Lay's, right? Because now they're making potato chips with bad potatoes, right? So the supplier will kind of be shafted. Chip company kind of shafted with type 2. All right, does that make sense? Yeah. Let's do another one. And remember, the seriousness really depends on whose perspective you're looking at, right? Let's take another one of those. Water samples are taken from water used for cooling as is being discharged from a power plant into a river. So we're taking water samples, water used for cooling as it's being discharged from a power plant into a river. It has been determined that as long as the mean temperature of the discharged water is at most 150 degrees Fahrenheit, there will be no negative effects. What does the at most mean in terms of, what is it, at most here? What does at most mean in terms of an inequality? That's less than or equal to, right? There are no negative effects. So that means that we would be happy with this. When will we start seeing issues? When it's over that, correct? To investigate whether the plant is in compliance with the regulations that prohibit a mean discharge above 150, 50 water samples will be taken at randomly selected times, and the temperature of each sample is recorded. So what are the hypotheses? HO is equal to 150? Why do I not put less than or equal to for the null hypothesis? Because it said at least. Do we care if it's lower than that? No, that means they're in compliance. When is it going to be kind of iffy? When it's equal to 150. It's out of compliance when it's above, right? Anything that's lower than that, fantastic. 150 and over 50, 150, nope. All right, what are the type 1 and type 2 errors? So let's start with type 1. Reject HO when HO is true. This is true, but you reject it. So for type 1, you say that the water is over 150, but it's really not. Does that make sense? Listen, this statement is true, but you reject it. So literally, you say, this is not true. You conclude this. That's not true, right? Like, this really is true, but you say it's not. So you say it is over 150 when it's really not over 150. What about type 2? You say it's over 150 when it's not. So type 1, you decide the temperature is really above 150 when it's really below. For type 1, you say it's above 150 when it's really below. And type 2 would be what? When the side isn't above 150 when it really is. All right, I want you to think about those two errors. Which one's worse? Well, it does depend. If you're talking about polluting a river with water, when are you going to pollute it? When it's over 150, right? So which error is talking about maybe polluting that river? Type 1 or type 2? Deciding temperature is above 150 when it's really below. Is that okay if we do that? Well, we might accuse the power plant of something, but is the environment okay? Yeah. What about type 2? Means the power plant is getting away with dumping warmer than normal water, or warmer than regulation water in. So most people would agree that type 2 here would be worse because it's endangering the ecosystem. So you're right, Henry, it does depend. But when we're talking about a power plant versus the, environment, which one should we weigh more? The environment should weigh more heavily, as we should take care of that versus the. Yeah, from that company's point of view, they're going to switch. That's why it says most people would agree. Here, how about this? Most people would agree, except greedy power plant peeps. Right? They would say that type 1's better, or type 1's better. Is that good? You guys with me? Okay. I want you to try this one on here. Try that one. All right, let's go over this. Hypotheses. What do you guys think? So medicine is not toxic versus it is toxic. Safe is fine. So medicine is safe versus medicine is not safe. That could be the same thing. You guys with me there? What's type 1 error? Saying that the medicine is toxic when it's not. Okay. Type 2? Do you guys agree that the medicine isn't toxic when it really is? Okay, so I have a question here. type 1 error, saying that the medicine is toxic, but it isn't, versus saying, medicine isn't toxic, but it is. Which type of error could be a little bit rougher here for, I don't know, the consumer?
How bad is that infection?
Very
Consumer want to die.
Okay, when we're looking at this, I think it's clear. Which one is the worst issue? Like, definitely type 2, because then you're giving people toxic medication when you're telling them, hey, it's not toxic.
Overpopulation.
Oh, all right.
Thanos.
Yes, this is an Avengers kind of plot, right? Okay, so we would want to really, really reduce the probability of making type 2 error, correct? How do we do that? Increase sample size and increase alpha. So we want probably an alpha of 0.10. We probably want a pretty high sample size, okay? And that will lower the probability of you making a type 2 error. Does that make sense? Okay. Now, this is literally what it is that we're doing. Do you guys see this guy? He's sweating bullets. You want to know why? He's walking a fine line between type 1 error and type 2 error. And that's what you do. You're walking the fine line. So what we do is we assess which error is going to be greater. And you should make your alpha level correspond to which one you want to, I guess, reduce. So in that case, we wanted to reduce type 2. So high alpha, high sample size will reduce probability of making type 2 error. This is why we most commonly use 0.05. 0.05 helps balance the errors. Okay? So kind of think of it like a scale. But if you know one error is far worse than the other, because I think type 1 error in the last example was, you're saying that the medicine is toxic, but it's not, that's okay. Because people are not taking toxic medication. They will never take this medication. Probably the pharmaceutical company will be a little bit irritated, but they'll get over it. The other people who could die by possibly taking that toxic medication, that's the big issue there. It's the big ethical and moral issue behind it. So that's what you do to decide what alpha level that you should be using when you're doing a hypothesis test. So it is a fine line, and to help you decide what line you need to be on, you're going to use the scenario at hand and your type 1, 2 errors. Does that make sense? So hopefully now this answers the question of, why do we always use 0.05? Why is that the most common one? It's to balance the type 1 and type 2 errors. Unless you really look at the scenario and you say, type 2 is non-negotiable. We must reduce that. So then that's when you adjust your alpha level. Or you say type 1 cannot occur. We cannot have type 1 error. So that's when you reduce alpha level to be super, super small. You'd say, like, you look at the scenario and you say, okay, type 1 is worse than type 2, right? How do I reduce type 1 error? You make a small alpha with high sample size. You do those two things to reduce type 1 error. I would say as low as you need to go. Well, you can't make alpha 0, but you can make it like 0.005 if you need to. If it's really bad, you can make it really low. So that means you would need a lot of evidence to reject HF. Does that make sense? Because you can only make a type 1 error if you reject HF. All right, ladies and gentlemen, that is type 1, type 2 error. Tomorrow, what we're going to do is pick up with power of a test. We're going to do the 2018 investigative task to kind of highlight what is power and kind of take a look at it tomorrow. Does that make sense? All right.